Hey guys, welcome back to another video. So I have uh, so today I wanted to discuss about a visualization tool which is a Seaborn. So we must have used uh, Seaborn somewhere other way, like when I'm exploring some data sets, it could be IPL or crop production, Netflix data sets. So I might have used uh, I had used Seaborn visualization library. So I just wanted to uh, go through the entire Seaborn library end-to-end guide. Why we prefer Seaborn over Matplotlib and what are all the types of plots we have in Seaborn, univariant, bivariant, something like that. And when do we use those kind of plots and also some customization functions. So I'm gonna talk about all these things. So it will be like interesting session because we might be wondering why we are using this term HUE or KDE in some plots. So I'm gonna uh, take you through all these simple each and every syntax and each and every keyword and how to utilize it and why we are using that. And first, let us start the session by by explaining the Seaborn over Matplotlib. So basically, Seaborn offers several distinct advantages over other visualization tools, making it a popular choice uh, for data scientists and analytics working with Python because it's built on Matplot foundation integration. It is internally integrated with the Matplotlib and also statistical visualization capabilities, and it has a very simplified syntax, and it has integrated data set handling. It has some inbuilt data sets, and also we can able to handle or we can able to access those inbuilt data sets, and and also we can plot some complex plots by using Seaborn. And we do have wide range of plot types in Seaborn. So basically, the Seaborn's strength lie in its ability to simplify complex data visualization tasks with its high-level interface. So the that is why in most of the cases we prefer Seaborn over other visualization tools. Okay, so let's start the session with command pip install Seaborn. If you want to install the Seaborn library in your Jupyter notebook or anywhere in the in your Python environment, then this is the syntax: pip install Seaborn. So if it is already there, then that's okay. But if you wanted to install the Seaborn library, so as soon as uh, we run this cell pip install c1, so it got satisfied, the requirement already satisfied because the library is already installed. So that is the reason why I'm getting this is so it got installed, and I'm just importing cban as alias name SNS, and I'm importing matplotlib pyplot as pplot plt. uh, so I just wanted to set the style. So as in if I wanted to set the grid style, or for now we just wanted to talk about the grids. So if I wanted to set the grid style, sn is dot set and the style is equal to white grid I wanted. So in the entire session I want the grid is white grid. So that is the reason why here only I set the style is equal to white grid. So let me run this. Mm, then we'll be able to see all the graphs with a white grid. So as I said in the introduction video, so SNS, this Seaborn has some inbuilt data sets where we can able to access those data sets and we can able to do some data analysis as well. So I'm gonna take one data set which is tips data set. So where we have restaurants bill data along with the some tip amount and the day. So let me import that data. So if I wanted to import any kind of data set from the SNS, the syntax is like sns.load dataset, and you need to pass the dataset name. So here I wanted to use the data set is tips, because it's a very basic data set, so that we will be able to utilize it for all kind of graphs. So in this session I'm going to utilize a lot of different kinds of plots, so that is why I'm importing a sample. So let's consider this as a sample data set, and I'm gonna apply, or I'm gonna use this data set for different kinds of plots. So I have loaded the dataset tips, and if I wanted to see the head of the dataset, so this is how it looks. It has total bill. This is a total bill amount, and out on the $16.99, there is a tip of $1.01, and the gender section is also, we have column for female and male, the customer details, and also whether the customer is a smoker or non-smoker, and the day they visited the restaurant, and the time. Is it for a lunch, a dinner, breakfast, something like that, and the size is also, we have this these columns: total bill, tip amount, and the gender of the customer, and also whether the smoker or not, and the day they visited, and the time in that particular day. So this is my data set. So I'm gonna visualize a flow starting from basic graphs to some advanced graphs, and also I'm gonna tell about in which scenario what kind of the plots we can use. So first we'll talk about a univariate plot. Basically the univariate plot nothing but a single variable. Univariate plots are visual representations of a single variable's distribution and are used to understand the basic properties and patterns of that variable. So for example, let's take the above data set. If I wanted to see the patterns or the properties of any column, so any variable, so only single variable. If I wanted to look at the one variable and its the pattern, how it got distributed, how it is varies. So if I wanted to look at one variable, then this univariable plots are useful. In univariable plots, we have different kinds of plots. First, first plot is distribution plots, like histograms. In distribution plots, we have histogram. So in histogram, so if I wanted to plot a histogram for a single variable called a total bill. So if I wanted to see the distribution of total bill amount for entire data set, how it got distributed, and so I'm gonna use this histogram. So if I wanted to import, or if I wanted to use histogram, the syntax in SNS, sorry, Seaborn, the SNS dot histplot, then you need to pass the data. So here, since I wanted, I'm plotting a graph for a univariate plot, since I wanted the distribution of only one variable, so that is the reason why I'm giving this column tips of total bill amount and the KDE. KDE is nothing but the kernel density estimation. KDE is a non-parametric way to estimate the probability density function of a continuous random variable. So total bill is, if you can see the data type of total bill is a continuous integer, continuous variable: 16.99, 10.34, 21.01, 23.68. So this is a continuous variable. S- and it will give me this, you can see in the below graph. So if I run this with, I give the plt.title for the title, and so if I give the so you can see the bins. These bins represent interval data. For example, I have the bill data from like $16, $10, $21, $23, and $24, right? So these bins, if these bins are the intervals. Like for example, I am partitioned my data or total bill amount into some intervals, like let's put $0 to $5 into one bin, and 5 to 10 I am giving here. If I don't give bins, then it will, by default it will take some value. If I give bins is equal to some specific value, some 30, then the 30 will bins, sorry, I gave bin. By default, see, 30 bins are generated because the entire total bill section is divided into 30 intervals, and you can see out of 30 intervals where the frequency of the bill amount is more. So from $10 to $20, you can see the number of customers are more. The customers are paying, like they are ordering a bill or they are purchasing the items worth in the range of 10 to $20 only. If the total bill is at 10 and 20, there is a frequency, more number of bins are present in 10 to $20. So that is what, that is the use of bins. So if I remove this bins, then by default it will take some uh, distinct intervals. So if you wanted to specifically enter bins is equal to 30 or 40, then the entire data will be segregated into that number of intervals. Like 30, if I take 30, 30 intervals, if 40, 40 intervals. And KDE, so that is about this bins and the frequency, how many times the bill amount is falls in that interval. And the KD is like, if you can see one line rise continuous line, it is increasing, and this thing, this line is called a KDE. That is called, if KDE is equal to true, then we can see this bins along with this line. So if I put KDE is equal to false, so I'm not gonna see that line. So only bins we can see, bins with the frequency. So that is what, that is the use of a KDE, kernel density estimation. So where you can see the distribution non-parametric way to estimate the probability density function of a continuous random variable. That is how. So if I wanted to look at a single variable distribution by using a histogram with the KDE is equal to true, and if I wanted to set the bins, then you need to pass bins is equal to the required number. If you want 30, then pass 30. If you want 50, then bins is equal to 40. As per your requirement, you should pass the numbers. So when you plot a KDE curve over histogram, it provides a visual comparison between the binned data histogram and the smooth density estimate, which is a KDE. This combination allows us to see both the discrete and continuous representation of the data distribution. So you can see this bins will give me a discrete distribution, whereas this curve will give me the continuous distribution of the data. So that is the goodness of using this histogram. Histogram with the KDE will give me the discrete and continuous representation of the data. So here I wanted to look at the total bill section. It gave me a discrete distribution by bins and also a continuous distribution with a KDE line. So that is how you can plot a histogram whenever you wanted to plot for a univariant uh, plots. So under univariant, I have a second is box plots. So box plots are nothing but, so you can use the syntax is like SNS dot box plot. And since this is also comes under, like I'm talking about a univariant plots. So under univariant plots, so I just wanted to look at the only one variable, which is total bill, and I'm passing the title and show same thing above histo in the hist plot. I just give hist plot. Here I wanted to plot a box plot. So box plot, this is how if I run, then you can able to see the data distribution. Same similarly, so how you can see the distributed area from 10 to 20, the more distribution is there. Similarly here also from here to here, the data is more total bill amount is present here. So these are all the outliers. So this is how if you wanted to plot a box plot on a single variable. And if I wanted to plot a violin plot, so this is how you can plot a violin SNS dot violin plot, and you need to pass the variable. Here I just wanted for a one variable, so x is equal to tips the total value, then title and show. This will also give me a data distribution. See, so similarly, so same, the total bill amount is maximum at 10 point something to 20 something. So here the more data points are presented. So this is also one way to look at the distribution of the data by using a violin plot. So that is one thing. And so that is about univariant plots. So if you wanted to look at the data with a single variable, use a single variable with the histograms, with a box plot and with violin plot. So if I have a relation, if I have two variables, so that is where this bivariant plots will come into the picture. So bivariate plots are visualization that displays the relationship between two variables. So these plots are used to understand how one variable is changes in relation to the other, revealing patterns, trends, and potential. So for example, let me plot a scatter plot under bivariant. So I just wanted to look at the relationship between two variables. So I'm going to plot the same scatter plot. So this time, since I need two variables, so I wanted a relationship between total build and tips. So I need to pass x is equal to total bill, y is equal to tip, and my data is tips data set. So this is tips data set, same, and I want total bill versus tip. So x variable is total bill and y variable is tip. So let me plot this scatter plot. Same title I am giving, scatter plot of total bill versus tip. So now it will give me the relationship between two variables. So total bill, if the total bill is around 10, then the tip is like a maximum of $4. You can see more of $1 to $2. So if the build amount is 10, so if the build amount is 20, the tip amount is more present here, like around it is 3 to $3.5. If the build amount is increasing, the tips are also increasing. So if the if the total bill amount is 30, then so there is tips are like 6, around 5, something like that. If the 40, then the highest value is like 7. If the bill, if the total bill is 50, then the $10 will be the highest tip. So this is how, if you wanted to look at the data distribution or the relation between two variables, then you can use this scatter plot, nothing but a bivariate plots. Under bivariate plots, this is one of the uh, plot, which is a scatter plot, where you can see the distribution or relationship between two variables. And the next one is a line plot, basic line plot, but with the two variables. Here we just used this is a line plot again, but this is a histogram. So here a normal line graph with the two variables. So x I'm giving the size, then y is a tip amount, because we have a variable called size also, right? I wanted to see the relationship between the size and the tip, how it varies with increasing in one, and is it increasing, other variable is increasing or decreasing. So let me run this and my data is tips. Okay, so if the size is increasing, obviously the tip is increasing. See here, my size is 1, the tip is also equal to 1 something or 1 point something. If the size is increasing, the tips is also increasing. There is a linear relationship. So and so that is what, if you wanted to plot a line graph between two variables, so this is how we can plot, just SNS dot line plot. SN, if I wanted to plot box plot, SNS dot box. Histogram means histoplot. Scatter plot means scatter plot. Simple syntax. So that is the advantage of using Seaborn over other visualization tools. The syntax part is simple, and as well as so we can get this, I mean, nice graphs with a simple syntax. Or complex data, while working on complex data also, by with a simple syntax we can able to look at the data for complex data sets also. So this is normal line plot and bar plot. Bar plot is nothing but if I wanted to look at the data. So basically, when do we use a bar plot? Nothing but, so when we have a uh, the categorical variables, like my columns or variables are in categorical, then we should plot a bar plot so that the each category will be displayed as in in each bar. Categorical plots. So that is where we should use the bar plot. A bar plot displays the frequency or count of categories using rectangular bars. The height or length of the each bar represents the value. Basically, we will use to compare the counts or frequencies of two different categories. When you have when we will use this bar charts, so when we have categorical data and want to see the distribution of each category. So here I'm passing x variable as a day and y variable is a total bill, and this is my data and this is the title. So I just wanted to look at the total bill amount day on day. So how it got varied. So on Thursday, the total bill amount average is like around 16. I could say 17, I guess. And Friday it is like this, Saturday it is like this, and Sunday it is more. So that is how, if you have a categorical variables and if you wanted to see the relationship or how the data varying with the categorical variables, then you should use this bar plot. The syntax is SNS dot bar plot. Then you should pass two variables and the data is equal to, you can give the data source. That is how we can use this bar plots. And the next one is again a box plot with the two variables. Since here we used box plot with a single variable, now I wanted to use the same box plot with the two variables. So I'm giving day and total bill same, and I just wanted to use the box plot. So similarly, you can see Thursday, Friday, Saturday, Sunday, categorical wise, how the data distributed, the data of total bill amount distributed. So it is distributed more at 11 to 20, and these are called the outliers, which is 1.5 times of IQR. So we are going to talk about all these things in later when we started this machine learning algorithms. What is IQR already covered in the statistics interquartile range, and why we need to calculate this 1.5 times of IQR in to identify the outlier, something like that. So this range is called 1.5 times of IQR. So the data which is present above the 1.5 times of IQR, those are called outliers. So when we wanted to handle the outliers, so we can eliminate this and we can build a model. So that is a box plot for with the two variables and categorical plots. So we are done with a single variant or univariant and bivariant, and now we have a categorical. So since this is also a categorical but with the two variables, now I have the data categorical plots. So categorical plots are used to visualize data when one or more variables are categoricals. This plots helps in understanding distribution of categories, comparing the frequency or count of categories, and examining the relationship between categories and continuous variables. So for example, if I wanted to use this count plot, when do we use count plot is like to count and compare the number of occurrences of the categorical variable. And when we need a simple count of categories, so something like that. Here, if I wanted to look at the day wise and count how the day and with with the count. So Thursday we have 60 plus customers visited, and Friday which is very less, and Saturday Sunday it is obviously more since because of the weekends. That is how, if you wanted to look at the category wise data with counts, that we should use this count plot. And uh, so next plot under categorical plot is like strip plots. So strip plots are used to display individual data points from one or more categories, often with some random noise to avoid overlap. So they provide a clear view of distribution of data within each category, making it easier to see patterns, clusters, and outliers. So almost you can see the data. So Thursday, how many customers are visited, and what is the total bill amount on Thursday, each customer wise, each entry wise. So here you can see the data distributed like this on Thursday and for Friday. So that is what it will give me the category wise. Category wise we can get. So this is how you can use the strip plots by passing the data variables. If I wanted to look at the two variables, categorical variables. So this is the syntax, and that is one thing. And if I wanted to use the swan plots are used to visualize the distribution of individual data points within the categories. So this is within the same categories. They arrange points to avoid overlap, making the distribution and density of the data clear. So you can see this swan plot and this strip plot. So here there is data with overlaps. So you cannot see the data points clearly. But whereas this swan plot, there is no overlap. So data points are distributed very clearly. So that is what if you wanted to see the data point with the clean and also the see the distribution of each data point, then we will use this swan plot, and we should pass the x is equal to the variable and two variables, then the data. So my categorical variable here is my day, and this is my total bill. I wanted to see the day wise total bill. So this is how we can see without overlapping of the data points. And the next plots are like matrix plots. So far we covered univariate, bivariate or multivariate, and also categorical plots. And now we are gonna talk about matrix plots. So basically matrix plots nothing but to use to visualize the data that involves multiple variables. Okay, so this now we'll talk about the matrix plots. So matrix plots are used to visualize data that involves multiple variables, showing relationships or distributions and interactions in a structured matrix format. For example, I have the data in matrix format 2 by 3, 3 by 2, 4 by 4, something like that. These plots are particularly used for exploring data sets with many variables, enabling the detection of patterns, correlations, and outliers. So basically, when I wanted to see the correlation between the uh, different variables or different features and target variables, then I should use this matrix plots. In matrix plots, one of the plot is heat map. Heat map uses color to represent values in a matrix with each cell's color intensity corresponding to the data value. So the syntax is like SNS dot same thing. Now this time I'm using flights dataset. So SNS dot load dataset, flights dataset, and pivot I'm giving flights dot pivot month, year, passenger, and SNS dot I wanted to plot a SNS dot heat map, and my data is flights pivot, and not I'm giving true annotations. This annotations, and FMT is gold D, and the color this is C map is also for colors. So if I run this, then I'll be able to see the heat map of all the month wise and the year, how many flights, something like that. So if you are working on any data set and if you wanted to look at the correlation between the variables, then please we can use this heat map to look at the. So this is the color shows that the intensity and also how the data, the columns are related, like what is the relationship between these two features. So in these scenarios, we can use heat map and cluster maps. So cluster maps are nothing but a cluster map is a type of a heat map that includes hierarchical clustering to organize rows and columns based on a similarity. So hierarchical data, so something like that. SNS dot cluster map, same, I'm using the flights pivot table as my data, and color I'm giving this, and standard scale I'm giving 1. So this is how it will give me like hierarchical relationship. The same, the my features or the columns, and also my target variable or other columns, the correlation between the two or correlation between the columns, it will give me the cluster map. So that is how you can see the correlation between the variables. And pair plots. So pair plots and joint plots. So pair plots nothing but the pair, it creates scatter plots for all pairs of variables in dataset, uh, along with histograms or KD plots for the individual variable. For example, if I wanted to plot a pair plot for tips dataset, entire dataset, so it will draw for each and every column. So see, you can see I have total bill tip size and total bill tip size. So this is how you can, it will, the pair plot creates scatter plots for all pairs of variables in the dataset along with the histogram KDE. So this is a histogram uh, or KDE plots for the individual variable. So this is a histogram where you can see the number of frequencies with the total build amount, and also you can also see this is total build versus total bill. This is, and if you want a tips versus total bill, so this one. If you wanted size versus total bill or size versus tips, size versus size. So this is how you can plot pair plots and joint plots. So joint plots nothing but are type of visualizations that combines different types of plots to show the relationship between two variables as well as the individual distribution of each variable. So they are useful for exploring correlations, distributions, and trends between the variable. So it is nothing but again, it the application is similar to the heat map and my uh, this cluster map. So, similarly, if I wanted to look at the data or if I wanted to get the correlation between the two variables, so I can get it by using this joint plots also. So SNS dot joint plot and the two variables I'm passing. So this is how you can see the correlation between the two variables. Here you can get the histogram along with the data distribution in like this. So this is how you can see the joint plots. Basically, it combines two types of plots, histogram and also uh, it is like a scatter plot, something like that. So, and next is like important thing, regression plots. Regression plot, nothing but is also known as a regression analysis plot or regression diagnostic plots are used to visualize and assess the relationship between variables, particularly when one variable dependent or response variable is predicted by one or more other variables, independent or predictor variables. So these plots helps in understanding the form and strength of the relationship, identifying outliers and evaluating the goodness of fit of a regression model. I hope when we are studying this straight lines in our mathematical tutorials, so you might have heard y is equal to mx plus c or y is equal to mx. So that line is nothing but a regression line. So that is a very important thing in this machine learning. So you might have wondered when can we use this y is equal to mx plus c, all these equations, are this useful or not? So this is this is where we can use in a regression analysis to see the if y is equal to mx to see the relationship between one variable on y. So for example, if I take x and y are my two variables, and if I wanted to see the relationship within, so x is my dependent variable, sorry, x is my independent variable, y is a dependent, y is my, y depends on x value, x is independent value. So when we there is there any change in x which results in the y, so that is why y is a dependent variable, x is a independent variable. So that is where this regression plots, all these things come. So under this regression, Simple linear regression. Simple linear regression plot is a basic visualization that shows the relationship between two continuous variables. Like I said, if I have the regression line x is equal to, or y is equal to mx, or y is equal to mx plus is something like that. So I have two variables x and y. One is dependent and one is independent variable. If I wanted to see the relationship between two continuous variables, then I can use the simple linear regression, typically used when one variable which is independent and is used to predict another variable, something like that. So here I'm using this simple linear regression plot, LMP plot. X is equal total bill. I wanted to see the linear relationship between total bill and the tip, so that it will give me how the tips are getting as per the total bill. So data is my tips, and let me plot. So this is my regression line, nothing but the line which is crossing or which passes through most of the data sets. So again, we are going to cover about it in coming machine learning videos. So for now, we'll talk about this plot. So here you can see the total build amount and also tip. So total build amount is increasing, and also the tip amount is also increasing. There is a linear relationship. Then if I draw this regression line, so this is my regression line. So this is how you can see regression line. So that is about a simple linear regression. And multiple linear regression means so multiple the relationship between different variables. So this time I just wanted a relationship between total bill and the tip, and I'm giving HUE nothing but. So here you can see HUE nothing but it will show, or it will give us nice idea about the categories. So it will, by default, it will apply the colors. So if I give a different category, so I have a smoker category in my data set. So I'm giving HU is equal to smoker. So by default, it will apply. Uh, See here you can see the plot. HU inside it will show the smoker yes and no with some colors. So in the same column with a single data points, each data point, whether this customer is a smoker or non-smoker. So that is how it will represent. So that is where we can use this HUE. So that is how you can see, or you can plot a multiple linear regression line. And if I wanted to do some customizations in Seaborn, so we can do that as well. So this is like again setting a palette. Palette is nothing but the automatic colors. Though this, if I pass this syntax, then the color will be applied. There are a lot of styles. So SNS dot set palette. Then if I wanted to plot a box plot x and y and data, so that is how you can set some, or you can do some customizations as per your requirement. And if I wanted to apply some style and context, so here HUE, we spoke about HUE, right? HUE is typically used with categorical variables. It assigns different colors to different categories within the variable specified. So, and context and style. So if I wanted to do some customizations for context and style, so SNS dot set context. This sets the context parameters for the plot elements such as font size and scaling. And for SNS dot set style dark grid, this sets the overall style of the plot, affecting element such as grids, background colors, line styles, something like that. So this is how you can set context and styles. If you wanted a different style and different context, you can do that as well, and you can do some customizations. And this is normal. If I wanted to add some titles and labels, plt dot title, plt dot x label, y label, we should name it. And if I wanted to save the like the graph, the visualization image, so we can do that as well. So I'm plotting this box plot. I wanted to save it. So save pig, sorry, save fig, save pig. So it will save the figure, this image. So you name it and it will be saved in the. So that is how you can save the libraries. And these are like some advanced visualizations like facet grids. So facet grids, also known as facet grid in Seaborn, are a powerful technique for visualizing data across multiple subsets of a data set. They allows you to create a grid of plots where each subplot represents a different subset of the data, typically defined by categorical variables. Facet grids make it easier to compare relationships within subsets and across the entire data sets. So basically, if I wanted to see uh, different subplots with the subplots within the same data set, so that is also we can do by using SNS dot facet grid. So different grids with the different categorical variables. So joint grid. So if I wanted to join, like above we discussed about joint plot, so same thing, this the joint grids, joint grid. This is how you can do. So this is like if I wanted to do some real world examples, we need to pass our required data set name. So that is how. So I hope you might get a good amount of information about Seaborn, how to use or when to use different kinds of plots, or customizing some plots or coloring, and when to use different kinds of plots. If I have a continuous discrete variable or if I have a categorical variable. So you might be having some doubts earlier. So I hope this will give you at least some idea when to use a different graph and how powerful the Seaborn library is. So if you are getting or something out of these videos, please subscribe the channel, please like and share and comment on the video. So thanks everyone. Bye.